Thank you, Director Peterson. Good morning to the board and the public. I'll be presenting an overview of the white paper. There's a lot more detail in the white paper. As Director Peterson alluded to, we're not intended to go into that level of detail in this presentation, but we'll be hitting on these major points that Roger just presented. So I'll be talking about the WaterFix infrastructure, the physical facilities, particularly the project features, and how those meet the board-approved benchmarks for the Delta and ensuring reliability of supply through the Delta to Southern California. Discussing the constructability of the program or the project, looking at other large projects, whether that's tunneling or other large infrastructure projects in general, as how we stack up to those. Talking about schedule and risk, and the cost of the program, of course, and then how do we plan to manage the risk and protect Metropolitan's interest through our risk management approach and also through the plan to be newly formed Design and Construction Authority. So physical features of the project, start with those. Each of these have been set to, again, meet the 2007 benchmarks that were established by the board for ensuring reliability of deliveries through the Delta, either through sea level rise threats, seismic risks, and other risks that may be posed to those deliveries. In the North Delta, we have 3 intakes. I'll be discussing those. We also have the North Delta tunnels and the intermediate forebay. At the center of the project are the main tunnels. Everyone is aware of those, the twin 40-foot tunnels. And then in the South Delta, 3 components that will be discussed today are the Clifton Court pumping facilities, the modifications to the Clifton Court forebay, and then finally the head of Old River Gate. So the project extends about 43 miles from the North Delta intakes, 3 of those along the Sacramento River, down through the north tunnels to what we refer to as the intermediate forebay, then into the twin main tunnels, down to the Clifton Court pumping facility that's in the northeast corner of the existing Clifton Court. North Clifton Court will be modified to receive the water from the North Delta diversions, keep that separate from the South Delta diversions, which will be allowed to continue under these plans. So we'll have the ability for what we refer to as dual conveyance. You'll be able to divert water solely from the North Delta intakes, solely from the existing facilities in the south, or through a combination of the two. And then finally, in the lower right, you can see the head of Old River Gate. I'll touch on that a little bit later in the presentation. This is an overview of the 3 intakes. These begin with intake number 2, located about 5 miles south of Sacramento. Originally, there were 5 intakes when the program was sized at 15,000 CFS. Through the environmental review process and the comments that were received, the program was downsized to 9,000 CFS. The numbering of the intakes was retained the same for consistency through the environmental process, so we're left with intakes number 2, intake 3, and intake 5. These intakes are spaced approximately 2 miles apart from one another. The location of these intakes was determined by a technical team that was established between federal fish experts, state fish experts, DWR, and other experts in fish and aquatic studies areas. So these were all agreed upon ahead of time, and now the engineering team has gone ahead and engineered these and laid them out to those specific locations. You can see that each of the intakes are connected by a tunnel system. We have 2 28-foot diameter tunnels that will convey water from intakes 2 to intake 3. Then that will be transitioned into a 40-foot tunnel, and then from intake 5, we also have a 28-foot tunnel. This is a representation of how the intakes look today. These have evolved over time, but this is a proven technology for on-bank fish-screened intakes. There are several of these along the Sacramento River already and operating within their specifications. You'll notice the fish screens along the river. Then we have a series of box conduits that convey the water into the sedimentation basins where larger particulate matter from the Sacramento River can be settled out before that water drops into the tunnels. One thing to note here is that we have, as Roger mentioned, moved the pumping facilities from these locations down to the south. Again, this was in response to comments we received during the environmental process. And then we also modified the sedimentation basins. Originally, They were concrete basins, and those of you that are familiar with Metropolitan's water treatment plants, they're very similar to those, large concrete structures, and because of the nature of the geology in the delta, these are going to be pile-supported structures. So tens of thousands of cubic yards of concrete would have been required. Hundreds and hundreds of piles would have been driven to support these. We are now following an approach that is also used up at the Red Bluff facility north of Sacramento, utilizing earthen basins. This has helped us reduce construction impacts as well as our greenhouse gas footprint for the overall program. So talking about the north tunnels for a few minutes, I already touched on those, so I'll move through this rather quickly. There are 3 tunnel reaches, about 13.5 miles of tunnel, 2 28-foot diameter tunnels, 1 40-foot tunnel, and the purpose of these tunnels is to collect the water from the intakes and bring that to the intermediate forebay. In prior iterations of the project, a lot of the collection facilities in this area were going to be cut and cover pipelines. For example, dual conduits, 16-foot pipelines constructed in that soft material. As we got into doing the conceptual design, it was determined that tunnels would be a preferable way to go, both from constructability and also from potential impacts to the local communities in that area. So the intermediate forebay receives water from the 2 north tunnels, allows us to commingle those supplies and then split that water equally into the 2 main tunnels going south. Those are the 40-foot tunnels. The footprint of the forebay, water surface is about 40 acres. The overall footprint is approximately 100 acres. This is another refinement that we made during the environmental process. The original intermediate forebay was approximately 750 acres of footprint. We've been able to reduce that to 40 acres, kind of the bare minimum required for 2 things: to be able to feed the pumps with a consistent source of water 30 miles south, and then also to dampen any hydraulic surges that might occur if there's a power trip at the pump station and that hydraulic surge comes back. It will be dissipated in the intermediate forebay before reaching the Sacramento River. The main tunnels, twin bore tunnels. Things to point out here, they're going to be deep tunnels. The bottom of the tunnels are set right now at about 150 feet below grade. We're looking for ways possibly to bring those up to reduce tunneling costs and to make the project basically easier to install. These are going to be unique tunnels in that, unlike the Arrowhead tunnels many of you are familiar with at Metropolitan, these will be a single pass liner system. That means there'll be a 2-foot thick concrete liner with gasketed joints, and we'll be relying on the fit up of those segments and the gasketed joints to provide us a watertight seal inside the tunnels. The top photo there is the Port of Miami tunneling machine. It's about 42 feet in diameter, so very similar to our size. And the bottom photo is a 40-foot inside diameter tunnel that crosses underneath the Sea of China in Hong Kong. And I represent that photo just to show you how tight the fit up of these tunnel segments can be to allow us to mitigate any kind of seepage into the tunnel or out of the tunnel, virtually watertight tunnels. The next component of the program is the Clifton Court forebay at the south end. Currently, Clifton Court forebay provides the feed water to the Banks pumping plant. The Banks and Jones export facilities are on the far right of this slide. Those remain intact and are not being modified with the program. Clifton Court at 28,000 acre-feet of water will be modified so that the north half of the facility will receive basically the fish-free water from the north diversions, and the south half of Clifton Court will be enlarged back to almost its original size and will provide DWR the capabilities to continue on with their South Delta diversions when those diversions are permissible. Now I'd like to take a couple minutes and talk about the pumping facilities in the south. This is another innovation that we brought together during the environmental process. We relocated the pumping facilities from the Sacramento River down to the south of the project. So we have 2 4,500 CFS pumping plants located side by side, and you can see the blue dashed line are the 40-foot tunnels bringing water into those pumping facilities. This is a cutaway view of the pumping facilities. You can see the water will well up inside the pump well. We have vertical turbine pumps that will lift that water about 20 to 25 feet and drop that into the North Clifton Court. Keep it isolated from the water from the south diversions. We also have, as Roger mentioned, the capability under certain river conditions to divert water by gravity. Under high flow conditions on the Sacramento River, when the river stage is high enough, we will be able to flow up to about 5,000 CFS by gravity through the system without any pumping.